Hi, my name is Lal Kaur. I am working as the systems administrator of Cochin University of Science and Technology. In this presentation, I would like to discuss the campus-wide networking, which we have implemented in Cochin University of Science and Technology. To begin with, I would like to say something about the computer networks. So, what is a computer network? Computer network allows the sharing of resources and information among interconnected devices. So it is just um, um, a network which allows to share information and data, anything between the devices in that network. So that is a computer network. So the first computer network was ARPANET, which is Advanced Research Projects Agency Network. So that is the beginning of. I just an introduction. I'd like to point out those things. Now let us see what is the purpose of a computer network. So what is the purpose? So first one, it is to facilitate communications. That is, using a network, people can communicate with each other. Say using a mobile phone or using some land phone or using video conferencing or something. Just for communication. So computer network was first purpose is to communicate with each other. Now the next is to sharing hardware. So suppose in a room one printer is installed in one of the machine. So in the olden days before the computer networks were came into scene came into picture, only that person is able to print. Now, after the network, that printer can be shared with the other users so that anyone in that network can use the hardware. That is a printer. That is hard sharing the hardware. Now, let's see sharing files, data, and information. Suppose one file is stored in one of the machine, and another guy want to use that file, so that file can also be shared. Now, and also next is for sharing software. So nowadays the all the software will be placed in one of the servers in the internet. For example, if you have the PDF, Adobe PDF, or whatever it is stored there. So from there we will be downloading it. So all the users can share their software and the information research. Suppose an information is stored somewhere in the network. So that can be retrieved any number of times. So that is for information preservation. Then security, then speeding up the process. Say, suppose you want to say after the network came, this file moving is very fast. So this is the use of computer network. Now let us see the network classifications. We can have two type of classification. One is a wired technology, another one is a wireless technology. The wired technology, we are using twisted pair, coaxial cable, and optical fiber. So all of you will be knowing what is optical fiber, optical fiber, OFC. That is used for communication. And what are the main difference between these technology? So in the twisted pair and the coaxial cable, the electric signals are going, whereas in the optical fiber, the light waves are going. So that is a media of the wired technology. Now let us see the wireless technology. In the wireless technology, we'll be using some microwave station. So one point-to-point communication devices are there. So using a microwave, this wireless packets can be sent. Then using the satellites, communication satellites, the pictures can be downloaded from the satellite. Then the cellular and PCS system. Then the wireless LAN, what we are using nowadays in our home. Then the infrared communication. Also, this wireless technology, wireless technology is used. Now let us see the topology of a network. So basically, there are a few types of topology. The first one is the bus topology, bus network topology. So in the bus network topology, a common bus is used. It's called a common line, which is called a bus. That is used. This is a common line. This one. This is a common line. It is used to communicate with each other. So an information from if this guy wants to talk to this guy, so he can use this common bus, and you can see that all the guys are talking each other, what happens? This bus will be chopped. So many packets will be going in and around. So from here to here, from here to here. So there can be some collision. So the number of users here increased, then this bus is not sufficient. So let just like our transport bus or line bus. So if the number of users are increased, it is very difficult to hold those users like that. If the number of packets or number of information is passing through this network, that network will be chopped. This media will not be capable for holding that data. So that is a disadvantage of the bus network. Nowadays, it is not used. Now let us see the star network. What is the star network? So instead of this common bus, all these are connected to a node. Instead of this bus, a node, another computer, a powerful machine is here placed. It is replaced. So this powerful machine is shared with all the nodes, all the computers in the network. So likewise, it is designed. That is a star network. Now let us say the ring network. What is a ring network? In a ring network, these all the nodes are connected like this. All the communication. Well, suppose this guy wants to talk to this guy. He can go to either this way or this way. So he will be check the available shortest path. If this is the same path, if the distance between these two are same, he will check the first speedy path, and he will choose that path and communicate with this guy. Suppose this is lost, then he can take this way also. So likewise, ring is formed. In our network, we can use star as well as ring. It will be combined together so that the failure will be very less. So if in the star, one more node will be coming here, and this common hub will be connected with these nodes. So if this fail, then he can choose this star path. If the star is failed, he can use the ring path. So likewise, we can combine these two networks. In a mesh network, all this node act as a star, a center node. That means one node will be connected to all the machines. It's just like the router in our internet. In the internet, router will be connected to all other routers. So this forms a mesh technology. Now let us see the different types of networks. There are different types of network. One is the local area network. What is a local area network? If we take our school, our university, or our department, we'll be connecting in a particular lab. We'll be connecting all the machines together, so that will form a LAN. Now the personal area. What is a personal area network? That is person to me. That means that network is personalized, person to me. That is, suppose I have one laptop, one tab, and one mobile. These three can be interconnected. That is my personal area, personal connection. That is a personal area network. Now let us a home area network. Suppose we have a residential area, and we want to communicate with our neighbor. We can choose a network, and that is known as the home area network, right? Then next is a wide area network. So wide area network is our internet. That means different geographical locations are connected to each other with the LANs. All this LAN is connected to different geographical area of the city. That is a wide area network. Now let us see the campus network. This is a small network than this wide area network, but it is interconnected with limited geographical area. Now the metropolitan area network. So it is a large network that usually spans a city or a large campus. That is a metropolitan area network. So basically, and see the enterprise private network, then the virtual private network. This is an important thing. Virtual private network. What is a virtual private network? Or simply VPN. All have heard of this VPN. What is a VPN? Suppose we have a campus here. We have a remote campus there. What does these people in this campus do? And they will be connecting each other. They can talk each other, and it is actually a private network. Now, no information go outside. So, if the person in the remote location also want to join us, so we will consider them as a private network. So, virtually, we'll be creating a network. Physically, they are away, but virtually, we will be joining them to our network, so that they will have a feeling that they are in the same network. They are the main campus. So that is a virtual private network. Actually, this network is classified according to the distance and the criteria and the category. Okay. Now let us say internet. What is an internet? So it is connection between the two or more private computer networks using a topology, using a technology known as OSI layer. It's a protocol. That is internet. And coming to the point, internet. What is an internet? It is a global system of internet, government, academic, corporate, and computer networks. All the computer networks, suppose all the computer networks are combined together, that will form an internet. And you can see that it is based on some technology. What is technology? It is commonly known as TCP bar IP, TCP over IP. It's a pair of protocol. TCP is transmission control protocol, and IP is the internet protocol. So we'll be spelling it as a TCP over IP. Okay. Now let us see what is an OSI node. Open Systems Interconnection. That is a fundamental fundamental protocol followed in an internet. Okay. It defines a network framework. It's a framework to implement protocols in layers with the control passed from one layer to the next. We'll be coming deeply into that. So this is an OSI layer. So you can see that in the top area, it is called as an application layer. The next is the presentation layer, and that's the session layer, transport layer, network, and like that. In the bottommost, it is a physical layer. To understand this, I would like to give you an example. My example is that suppose the vice chancellor of this university need to talk to the vice chancellor of the other university, and not the personal thing. He want to talk officially. What he does? He will be dictating his message to his private secretary or whoever it is, and he will be drafting that network and using a cover or whatever it is. It will be sent to the dispatch section of the university. From the dispatch section, it will be this post office people will be coming there, and or we'll be sending that to the post office using a vehicle. Then what is that post office people do? He will take and given to the appropriate property post office through any media. It can be a train or a flight or whatever it is. And in that other end, post office people will give that letter to the concerned university. In the concerned university, invert section will be taking that letter. Then, from the invert section, he will see that it is that letter is for the vice chancellor. So, he will be directing to the office. From the office, it will be giving to the vice chancellor. So, that is a protocol we are following. We are following to send a letter from one vice chancellor to the other university vice chancellor. So likewise, in the internet, we can call it as packets. All the information we can call it as packets. All the packets will be. Suppose I want to Google, say for example, I want to get the page of Google, www.google.com. So that is in the application layer. The application, what is the application? My browser application. In my browser, I will give www.google.com. Now it will come down, and slowly it will be converting IP address, MAC address, everything. It is converted, and it will become the physical. That is our media. It can be a LAN, it can be a fiber optic cable. So that is a physical media. In the physical media, it will choose. That means it can choose the media's electric signals. It can be light waves or micro, whatever it is. So it will be passed to physical area. On the other end, it will be coming. There will be a layer like this, and the packet will be reaching the other end in the physical layer. Then it will go up and get the application to the other. So likewise, it's a protocol. So this is a low OSI layer. That is the way how we can communicate each machine. Okay, that is the OSI layer. Now let us that is the basic things. Now let us come to the IP addressing thing. What is an IP address? So IP address is a short of Internet Protocol address, and it is an identifying number for a piece of network hardware. So if you have a piece of network or network hardware means you can have a network interface card or a computer or a mobile. It will hold an IP address. So that identifying number is called an IP address. So having an IP address allows a device to communicate with other devices over an IP-based network like the internet. So if you have an IP address, this machine can communicate with the other machine having an IP address, right? Then it provides a delivery of packets from one host to another through internet. So after getting the connection between these two devices using the IP address, this machine can deliver the packets to the other machine. Okay. These packets are called datagrams, like small packets. So it is of 64 kilobytes in length. So that is an IP address. So let us see the classification of IP address. So basically nowadays we have IP version 4 and IP version 6. So what is IP version 6? 4. So nowadays we are using both one, IPv4 and also IPv6. IP version 4 it uses 32-bit address. So this, in the computer area, all our information is stored as zeros and ones because it is an electric pulse. So we will be using a binary digit. That is bit. So in IP version 4, one small packet, not the packet. One packet will hold a 32-bit. So an IP address will hold a 32-bit address. That is the IP version 4. Now if we think of IP version 6, when the IP version 4, all this internet users have been increased and devices have been increased. So many devices are coming up. Need IP, even if our phone, everything need an IP address. So if we took this 32-bit, then it is not sufficient for us to address these devices. So people think of increasing this 32. So they have developed a new technology, that is the IP version 6, and it uses 128-bit. And this 128-bit, it is sufficient for all the devices in our world. So this is the IP address. Now I am focusing on IP version 4 because in IP version 6, so many devices are not supporting, and we are not when convenient to use this IP version. It is very difficult to use this IP version 6. So I am having a lecture on IP version 4. As I told you, this is it having 32 bits long. That is how this 32 bits long is grouped. So it is like this. It is an 8-bit. This 8-bit, 888. So 8 into 4, it is 32. That is, this is in a binary notation. 0. If we convert this binary to decimal, it gives a number as 105. Likewise, the second octet, we can call it as octet. Octet means 8 bits. So this is the first octet, second, third, fourth. There are 4 octets. So the second octet, if we convert this binary to decimal, it will give us 254. Then this one 17 and this one. So this is the decimal notation of this binary notation. So since this is very difficult for us to remember, we will use a decimal notation like this. Okay. So that's an IP address. Then let us see the classification of IP address. So there are different classes in there, especially in the IP version 6, not version 4. The IP version 4, the address is classified in the class A, class B, class C, class B, and D. Then there we have the loopback and broadcast. Let us see what it is. In the IP version, in the IP A class, IP address A class, if the first bit is 0, then that IP address is A class. And you can see that there is a net and the host. It is written like this. What is a net and host? Net, as usual, it is actually the network. Host means that the host, the actual computer. So the IP address will contains a network portion and the host portion. So if we take this IP address, we'll be able to know which class it belongs and also which family, which network it belongs. So the first portion gives us the network. So we'll be knowing by seeing that IP address, we'll know which class and which network it belongs. In a B class, if the first 2 bit it was 10, then we will call it as class B. And if it is 110, it is class C. And if it is 210, it is multicast address. And if it is 4 1s and 0, it is not used this word. So it is termed as a reserved category. Let us see the class A. Class A, as I told you, it starts from 0 excesses in any number. That is 1 to 120. If we take 0 last one, it is 1. That octet. And the last one, it will be 126. That is, as I told you, it is say 0 and all ones here. Then it is a 126. It gives us 126. That is 1 to 126. In class B, this 10, the starting is 10, etc., etc. That is 128 to 198. That is class B. And class C, we get like this. Okay, we'll be coming deeply into that. And class D, like this. And here, like that. And let us see what is a subnet. What is a subnet? Say, if you take about an internet which is not, which doesn't have any subnet, I would like to give you an example for this one. Suppose we have a classroom containing 50 students. And as you know, if there is no class, what happens? The students will be talking each other, and there will be a huge loud the noise. We can hear a loud noise. And suppose we are conducting discussion. Say we are open. The students have open discussion. Form is there. So what the students do? They'll be talking each other. What 50 students are talking each other. What you can hear? He can hear nothing because we are hearing a lot of noise. So nobody can hear each other. So in a subnet like this, if you take a subnet like this, all this guy will be talking with this guy. He can talk this. Say this talking. He want to talk to this guy, but at the same time, this guy is trying to talk to him. This one is trying to talk to him, and all the others are trying to talk to him. What happens? There will be a loud noise, and he could hear nothing. And this guy also can't hear anything. So this is the same as what I have explained in the classroom. What we do, we will be split up into different groups. For example, say we have 50 students there. We will be grouping into 10. And if the 10 people are talking each other, all the others can hear. So that likewise, if this subnet is divided into different chunks, then there will be, we can reduce the collisions, we can reduce the noise in this internet. So like this, say it's like this. So in the previous one, it was a whole subnet. Now in this one, it is split into different groups. This A, B, C, D. So in this A, there are only a few nodes. So this guy can talk to this one, and other one can. It's not the collision can be reduced. Now let us see what is a subnet. Okay. What is a subnet mask? So if you take your computer and see IP address, you can see an IP address and followed with a number. Maybe starting from 255.25. What is this? What is it? And it is named as subnet mask or simply SM. So what is it? So that means it shows which family this IP address belongs. So this is a binary number used to compare the destination address to local IP address and to determine whether those destinations are on the same network or not. Okay. So that shows that in a subnet mask, in an IP address, if we use that subnet mask, it shows I belong to this family. So this is the use of this subnet. We'll be coming deeply into that. So let us see this one. Class A, we are taking this network range is, as I told earlier, this is an octet 1000 to 127.255. This 127 means this 0. First is 0, then 0011111. That is 127. Then the default subnet mask will be 255.0.0.0. And if you take class B, the range is like this, and the default subnet mask is this one. So I'm considering only the decimal notation. For class C, it's 192, like this, and the subnet mask. Let us see. And what I'll be deeply giving explanation for subnet mask. So you can see that if you take your machine, it contains an IP address together with a subnet mask. So to get the address, we'll be doing an arithmetical AND, binary ANDing. You will AND this 192 with the 255, 168 with 255, 0 with 255, 5 with 0. So after getting the result, that shows our IP address. So let us see what is 192. Converting this 192 to the binary, you will get a number like this. So in 8-bit by 8-bit number. The 168 will be like this. 0 is, of course, it is 0, 0, 0. And 5, it is 0, 0, 0, 1, 0. So this is converted to a binary number. Also, this subnet mask is converted like this. And then we will AND these two. So 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, 0 and 1 is 0, like that. Likewise it goes. And so finally what we'll get the same number. So ANDing this one, we'll get the same number here. So let us AND this 1, 1, 1, 0, 1, 1, 1 and 1, 1, 0 and 1, 0, 1 and 1, 1. So finally ANDing with 1, 1, 1, we'll get the same number. So then we'll be ANDing this one, we'll get the same number. Now let us see this one. So ANDing with 0, you must know that it is a 0. So ANDing with 0 will give us 0. So this portion, this number will become 0. 1 and 0 is 0. 1 and 0 and this is 0. So all the others are 0. So this is 0. So finally, what will be the network? So ANDing, after ANDing, what will be giving the result? It is this one, that is 192, this 168, this 0, and what is the first? It is 0. So 192, 168, 0.0 is the network ID. So this is the use of subnet mask. Okay. Now let us say a simple example for this subnet. We have a worksheet. You can note down this worksheet and get the network. So I would like to take a small break and you can take down this example and get the okay, let us come back. So I hope you have tried these numbers and try to get the network ID. So as I told, and as in the previous example what I have given, ANDing with 25 doesn't harm because all this will be 1. So this 192 will give us the network as 192. 168 will be 168 itself. 1 is 1. Then 25 and the 0 will give us 0. So the network will be 192, 168, 1.0. Likewise, all this one, it will be 10.0.0.0. And in this case, 172.16.4.2, what is the network? So this, you can see that all this one, and 252 after converting to binary, all the ones are not, all the 8 bits are not 1. Some of them will be 0. So in that portion, it will, this 25552 gives us, ANDing 252 will not give us proper number. That is, it will not give, say, as in this case, it will not give 8 as 258 by 8, ANDing with 255 will give us 8. It will not give, in this particular example, it gives us 4. Suppose it is for 5.2, that belongs to the same category, but the network is not 5.0. So in this particular example, the network is 132.16.4.0 because ANDing with 4 and 252 gives us 4. But if we AND 5 instead of 4, if we AND 5 and 252, it will not give 5, it will give us 4. So 132.16.4.0 will be the network. You can try this number with 5.2 also, right? So that is a worksheet for this particular. Now let us see how this subnet mask is used. Now let us assume that we have a machine 192.168.1.1 and it has a subnet mask 255.255.255.0, and this machine is trying to send a packet to 192.168.1.0, and it also has another subnet mask, maybe the same subnet mask, maybe 255.255.255.0. So let us see. Forget about this. For the time being, let us forget about the subnet mask of this one. So then, what happens? How to find this destination host? First of all, what it does? This 192.168.1.0, you want to send a packet to this one. So, in that particular packet, it will contain the address also. So likewise in our post office, in our letter. In a letter, what it contains? It contains our address of that particular recipient. So likewise, that packet will contain the address of the destination machine and also the sender, not or not only the destination, but also the source, the address of the source. What is the address of the source? It is 192.168.1.1 and 255.255. And this packet is sent here. And what this guy do? He have a subnet mask here. And how did he know that it belongs to another network? How can he have what? It is destined to this number. He will take the subnet mask. He will take the subnet mask and with one, and to this subnet mask, and it will find whether it belongs to this number or not. So if it is not this number, it is sent to another one. So ANDing the IP to the subnet mask will give the network address. Hence, both IP are ANDed and system will determine the network address. So it will get the network address and it will see whether it belongs to this network or not. So I will be giving you an pictorial representation. And see, this 192.163.1. So we want to know whether this is the same network or not. So he gives us a ping command 192.163.1. And in the network, you want to send a ping packet to this one, not here, to this one. So how does this line know this packet is to this one, not this one? So he'll take the address of this packet on the 3.1 and the address of this network, and it will go here, and that is 192.163.1. He has this IP address, and this IP address is ANDed with this IP, this subnet mask. So he will get 192.168.3.0. But what is the network ID here? It is 192.168.2.0. So since this belongs to 192.3.0, this is not in this family. So it will go to the next host. Here also this is broken, and it will check whether this one, the network ID, this network ID and this network ID is matched, and you can see that it is same. So this packet will be sent to this one. So likewise, this is the use of a subnet mask. Now let us see what is an IP routing. And in the internet, all the network is connected using a route. So this is a network ABCD. This is another XYZ. How it is connected? This is connected through a device known as router. So this is a router, and ABCD, this is a router, this is a router. So the best example is our traffic signal, traffic path shower. So in a router, it shows an arrow. This is to that destination. This is this way to that destination, like this. So a guy coming to the traffic, he knows which. If you want to go to west, it shows the going to west or a particular place. You have to go through this way. So likewise, the router is like that. Say suppose this guy A is coming here, and he want to go to Z. He'll be coming to router, this one, and router will contain shows this the path to go to this Z. So it will be coming here and get the destination. So this is the router. The router's job is to just get the packet. Shows that this, to redirect the packets to the destination. That is the purpose of the router. And a hope. What is a hope? Suppose we have, say, from this guy is coming to. Yes, he need to send a packet to this guy in this network. So he had to jump to this network. From this network, he has to jump to this one, then jump here. This is called hopes. This is called hope. Right. Hello. Now, here I would like to give an example for the routing. So this is typical routing. Next, now let us see how the packet travels in the internet. Say these are three networks. This network is 192.168.1.0. This is 2.0. This is 3.0. And the subnet mask is this one. So all the machines in this network will have a subnet mask, and the machines will be numbered as 192.168.3.123, etc. up to 254. Okay. Now let us take this guy. So he is trying to ping to. Ping means it is a command to check the existence of this machine, this IP address. So I would like to give a command ping to this machine. That's 192.168.3.2. Actually, you by looking at the figure, you know that is here. This is the machine 3.2. But because I am a human being, looking at the figure, I know which this number is here. But if you take a network, this guy doesn't know he is in this network or is in this network. Only thing he knows is his IP address and the network mask. So what will do? He want to ping to this machine, and he will take this one 192.163.2, and he will take his IP address and the subnet mask. And so I will be coming to a gateway. What is a GW? I denoted as gateway. What is a gateway? Gateway means just like our house. Our house has a gate. See, if we want to go outside, we'll be using one gate. Suppose we have two gates. Normally, some houses will be having two gates. One gate will be looking into another one road, and another one facing to another road. If you want to take the second road, you will be using the second gate. If you want to go to the first road, you will be taking the first road, first gate. So that is the gate. So every network has a gateway. Say likewise, also if we take two rooms, two classrooms, each classroom has two doors, and that is the gateway for entry and for going out. That is a gateway. Likewise, one of the machine or one of the device will serve as a gateway of this network. So in this particular network, I will be giving 192.162.1 as the gateway. Here, this 192.168.1.1 serves as the gateway. Here, 192.163.1 as the gateway. Right? And also, this is, since it is a router, it has two network, one or more network, that is router. And this, and the other end, this is this here we have two network. One network is point to this one, the other network one point to this one. That is, if you take our house as a gateway, and this is a gateway. This is the way pointing to the road, and this is the way pointing to our house. So we have outward and inward. So that is a network card. Here in a network scenario, it is a network card. And this is the external network card, and it has an IP address 10.0.0.1, and this is an IP address 10.0.0.2, this is an IP address 10.0.0.3. And now let us see. We have to send a packet to 3.0. That is, we are actually, this machine is sending a packet to this machine. So it will be, he will be taking 192.163.2 and with this, with the address subnet mask. So we will get 192.168.3.0. So he will be pinged from his. So first of all, pinging 192.163.0 or 3.2, he will check whether it is in our family. If this guy belongs to our family, so he will. But this shows that our family is 192.162.0. So definitely he knows it doesn't belong to our family. So what is a, hey, this guy does belongs to our family. So go to the gateway. He will send the network to go to the gateway. The network will say, you can send the packet to the gateway. Well, this is the packet. And in the packet, after coming this one, and this, since it is a router, and no route is there, no signal is there to where it has to go, this will not, that packet is dropped here. So it will be sent back that, hey, that I cannot go out. There is no route. I don't know where to go. So that packet will send back to this machine saying that I don't have any route. And also, so that packet is dropped. Now let us see what is the solution for this. The next figure, this I mean, let us take this one. This router will contain a routing table. That is, to go to 192.162.0, take this gateway. So here there will be a routing table. That is, this is the routing table here. Likewise, here there is a routing table. That is to go to 192.168.3.0, take this gateway 10003. There is a gateway, a routing table. Table is the table will be maintained. That is to go to there is a signal board that to show the destination, the path of the destination. That is 10003. And another table will be there that showing that to go to 192.1.0, take 10001 as the gateway. So this is the gateway. And to go to and our so this router will contain two tables. One is pointing to this one, another one pointing to this one. So what happens when we give this again? We will be trigger one command ping 192.163.2. So it will send to gateway with the 192.163.0, and there will be a table, routing table says that to go to 192.163.0, choose 10003 as a gateway. So the packet will be coming here, and here again in the router there will be a routing table, and that routing table says that hey, this 192.3.0 belongs to this network. So that network will be, that packet will be coming to this network, and ultimately in this network. In this network, the packets will go zoom around, and it will find 192.163. What is the number? 3.2. Well, it is 3.2. This machine, and it will find this machine, and it will give a response, say, going back here to this one and give, but hey, I have found this guy here, and you give a response here. So this is the way how a packet is traveled through the network. And this is some